If we have a function of two variables, f of x, y, and we're looking at the graph of the surface, z equals f of x, y, then the expression for the normals and the tangent plane simplify somewhat. So this we can also write as f of x, y, z is equal to 0, where f of x, y, z is defined to be f of x, y minus z. So if we take the partials of big F with respect to x, y, and z, then the partials of big F with respect to x and y are the same as those of little f, and then the partial of big F with respect to z is -1. And so we get the following. So the tangent plane to the surface z equals fxy at a point x0, y0 is fx x0, y0 x minus x0 plus fy 0, y0 y minus y0 and then minus z minus z0 is equal to 0. Or maybe just a more compact way of writing it, if it's understood that that's where we're evaluating it. Maybe a better way to just write it down is fx x minus x0 plus fy y minus y0 plus, or minus z0 equals 0. And just remembering that this is multiplication. We're not evaluating fx at x minus x0. Okay, so let's do an example. So in the example I've graphed here, fxy is x squared minus xy minus y squared. So the gradient of f will be 2x minus y times I plus negative x minus 2y j. And so the tangent plane at, let's take, for example, 1, 1, -1. This will be given by, okay, so fx is 2 minus 1 is x minus 1 plus, and so then negative, so that'll be actually -3 y minus 1 minus z plus 1 is equal to 0. And for example, the normal line at the same point is x, y, z is equal to 1, 1, -1 plus t minus 3t and minus t. Next, let's consider the surface z equals f of xy equals e to the negative x squared plus y squared. So that gives this sort of bump function. So in this case, we have fx equals, I guess, negative 2x e to the negative x squared plus y squared, and fy equals negative 2y e to the negative x squared plus y squared. So if we evaluate this, for instance, at the origin or above the origin, so at 1, 1, 0, we get fx equals 0 and fy is also 0. So the tangent plane at 0, 0, 1 is 0 times x minus 0 plus 0 times y minus 0 minus z minus 1 equals 0. But this, of course, simplifies to just z equals 1. And that we could have just sort of seen visually from the picture of this. So if we took it at maybe some other point where it's not as visually clear, so let's take it at 2 e to the negative 8. Yes, that is how math works. So then we'll get fx equals negative 4 e to the negative 8. Fy equals negative 4 e to the negative 8. And so if we took here 2 e to the negative 8, then here the tangent plane would be negative 4 e to the negative 8 x minus 2 minus 4 e to the negative 8 y minus 2, and then minus z minus e to the negative 8 is equal to 0.